So good afternoon, everyone. I know I'm right after lunch, so I'll try to keep it brief and maybe get some discussion going and maybe also keep you awake. Those are my goals. But my name is Miriam Leeser. I'm a professor in electrical and computer engineering at Northeastern, and everything I do is FPGA related. So I'm going to talk about artifact evaluation for the FPGA community. So what is an FPGA? I assume almost everyone in the room knows this. Back when I started doing FPGAs, which is before some of you were born, my husband was like, what's a field programmable gate? He's from New Zealand. He said, I know what that is. So he actually drew the logo for my lab. So he goes, if you have sheep in a field and you can move the gates, then it's field programmable. And then if I have an array of those, I have an array of field programmable gates. Anyway, that's not what I'm not talking about sheep. But basically, the real reason I'm bringing up what is an FPGA is for artifact evaluation, people create open source artifacts that they want others to evaluate. And is it hardware? Is it software? FPGAs actually have a unique kind of characteristic, and therefore it's a little different. So usually the artifacts that people want to be evaluated are code written in a high-level language or a hardware description language to map a design onto an FPGA. So occasionally people actually design new FPGA hardware, but those tend not to be the kinds of artifacts that people ask to be evaluated. So what's an artifact? So it can be hardware, it can be software, it can be data. I've got lots of definitions in this talk. But basically, we're interested in encouraging people to make their designs open source, available to others in the community, and the idea behind artifact evaluation is to give it a badge that says you've contributed to this open source community. So we always have in our artifact evaluation form the ability to say you're designing new hardware. We ask that it follows the Open Source Hardware Foundation definition, and I don't think any artifacts I've done all the artifact evaluation in this field for the last 5 years. I don't think we've ever had an actual hardware design. So it's always been, sometimes it's design tools, and a lot of times it's designs or something like that other people can build on top of. We also always ask for a DOI or some sort of stable identifier. This is very hard for people. They just want to share their GitHub, and the GitHub changes all the time. And it's actually very hard to get people to commit to, this is what I'm making open source, and I'm freezing it. It's not that difficult to do. It's just that people don't like that. So artifact evaluation's been going on. It came out of the software field. I think it definitely started with ACM, and it started with transactions on mathematical software. But basically, the idea is to establish the results in a paper by having someone independently reproduce them. So basically, authors can choose to identify artifacts that can be software, that can be data, but they say, this is an artifact that I want to have evaluated by someone in the community, and then they provide instructions and documentations describing the contents and how to use it. So I introduced artifact evaluation into the FPGA community. We followed the model that supercomputing set up back in 2016. They have the 22 website has the whole history. So we now do artifact evaluation for the major FPGA conferences and for ACM TRETS, which is the Transactions on Reconfigurable Technology and Systems, so the main journal in this field. The one FPGA conference that's missing from this list is FPL, which is the FPGA European conference. They have journal paper tracks, and we do badging for that, but they haven't been using it in the main conference. So once again, the whole idea is to encourage open source, sharing of artifacts, giving additional credibility to an article, and you can get badges if your results have been reproduced. So these are the ACM badges. ACM did this first. There's another slide very similar for the IEEE badges. The terminology is similar but not exact. So basically, the things we're doing are basically reproducibility. So getting another team to have the same experimental setup and to reproduce the results that someone publishes in the paper. The third tier is replicability, which we do not attempt. So that's a different team taking the tools and trying to apply it in a different situation. So that relates more to scientific software, I would say. But we do provide the reproduce available and functional slides. And the way we do that is we pair an author after a paper's been accepted. So this is not a double-blind process. We pair an author with an evaluator, and the evaluator attempts to run the code and make it work. IEEE is a little late to the game, but they also introduced reproducibility recently. And they have, like I said, very similar badges, not identical, but very similar definitions. Once again, we don't replicate. We do try to reproduce. So same hardware platform, but a different model. But interestingly, the IEEE badging rules are really not friendly to FPGAs. They're really friendly to software. So they haven't done that. They've just kind of introduced the whole badging thing, but they're basing the software badges off of artifacts being available in CodeOcean. And the designs that we evaluate just don't play well in a containerized CodeOcean environment with all the rules. They tend to be designs that someone developed that make use of a proprietary tool that doesn't play well in a container. And it's just, I mean, I just kind of find it ironic that ACM, the software organization's badges fit better with this sort of is it hardware, is it software target, and the IEEE rules play better with software. But if anyone knows who in IEEE I can argue with about this, I'm going to go out on that. So is an FPGA hardware or software? And you could argue it both ways, right? Many of the artifacts that we evaluate involve using a proprietary design tool, and they're, by definition, not open. You could argue that everyone should be using open source everything, but the state of reality is that's not the case. We are using proprietary tools, and we can't make the entire flow open. We can't fit it into this containerized model. So there's challenges. So there's a real movement to try to do more of this badging, artifact evaluation, encourage open source across software and hardware. But there's real challenges with this for FPGA designs, especially in the direction this is going. So basically, the artifact evaluation models that are really built up around code are just not a good match. And I'd like to find a good match for these kinds of designs and continue to encourage people to make artifacts available, to have open source, and also encourage more participation in artifact evaluation. So if anyone wants to answer the question about whether FPGAs is hardware or software, I'm all ears. Thank you.
Thank you, Miriam. I love that you've left so much time for us to debate this, actually, because I think it's a super interesting area. One quick question I had was, on the containerization topic, is that because you're not allowed to put the Xilinx set into a Docker and then ship that, right? I think their license prohibits that.
Yeah, the license have gotten more flexible. It's just that, I mean, their whole tool flow is like 2 gigs.
Yeah. It's also outrageously large, yes.
Yeah, it's outrageously large. It just doesn't play well. We had one group in Switzerland that tried to actually follow the rules, and I have a whole list of all the things that didn't work.
Yeah, so it sounds like
the other thing is you can't create a platform with the tools because typically someone develops a design with a particular set of tools. So different things you're evaluating my design might use a different version of other tools than you do. So we can't even come up with a standard, here's a standardized container we want to have in CodeOcean, and then we'll run all the designs on that.
Yeah, and I suppose the underlying sort of message in your presentation is that actually open source FPGA flows would solve all of this. Do I infer correctly?
It would solve the artifact evaluation. Whether your best designs would come out of those,
Sure.
that remains to be seen, right?
Sure.
I mean, there's always going to be people who want to do. And I have to say the artifact evaluation, and this is true in supercomputing and all the other communities as well, is completely voluntary. We usually ask authors to fill out a form, and the first question is, do you want to take part in this process? And that's only to get people to think about, oh, I could get my designs, I can make my artifacts public and get badges and be rewarded for that. So that's the only reason we do that, but most people opt out. So.
Okay, who wants to tackle the FPGA software or hardware problem? Olaf is closest.
Yeah, I'm curious about how many of these do actually get evaluated by a third party. Is that common?
So we've been doing it for the FPGA conference for 5 years now. A typical conference publishes, we only do long papers, not short papers, 25 or 30 papers, and we typically evaluate 5. So, so I would say 20 to 30% of papers do. Actually, the interesting questions happen is what happens when the evaluator doesn't match the results that's in the paper. That's all.
What do you think the pathway is to making this mandatory so that the results are actually useful for people?
That's a great question. A lot of people are very resistant to that. So I know my students are like, oh, I can't let anyone else see my code. It's not very good. There's that. There are proprietary. So you can actually get a badge to say something's functional and not make it public. So that's actually one of the choices. I kind of glossed over that. But there are people in startups and companies and things who publish something that's going to become part of a proprietary tool flow. The ACM badges. So if you're becoming part of a private, you might not want to be open. So artifacts available is a different badge than results reproduced. So you can actually have your results reproduced and earn that badge, but not make your artifacts available publicly. That's actually an option. But I don't think the community is ready to make this mandatory, basically. And I think it'll take a while. So we're doing it as a voluntary process.
Yeah, so, hey Miriam. So for the people who worry about these kinds of things, how do you cite an open source repository, and can you cite it? So I've seen people they'll put up a benchmark and they'll write a paper, and then they'll say, right, here's if you like my work, please cite it, right? Sort of thing. Other people don't really want to take the time to get a peer review paper through the process, so they don't do it. Can they still be cited in a journal?
Oh yes, so we require a DOI. So then you can cite the DOI artifact. That's actually a requirement for getting the artifact available badge.
As an answer to that, for getting a DOI for an open source project, there's a Zenodo.
Yep.
Where you can upload a snapshot of your stuff, you tag it, you get a DOI, and then it can be cited. Zenodo, Z-E-N-O-D-O.
And it's very straightforward, but people still don't like doing it.
No one's tackling the question, though.
So this is a comment that's kind of related to the containerization thing, which is that there's a halfway house, maybe, it's not free, which is that nowadays on Amazon AWS, you can ask for a so-called F1 instance, which is a virtual machine that comes with an FPGA, Xilinx FPGA attached. Further, you can get the virtual machine to develop for that FPGA, which has preloaded for free. No, when I say for free, no extra cost beyond your Amazon account costs. For free, the Xilinx Vivado tools and so on. So I was thinking there's two possibilities, two kinds of things I could imagine. One is, I don't know if that's possible to persuade Xilinx, why don't you make the same kind of thing available just for this purpose? It's not a public release of your tool, but it's a release in a container for an artifact that people can just evaluate it. So that's one approach one might try with Xilinx. The second thing I was going to say is that you could use that as a platform for these artifact evaluations, because you could show your stuff works on that platform, and then somebody else can reproduce it.
So we have used AWS in some cases. That's what the developer used. So we have used that for artifact evaluation. But actually, right now, I'm having a really hard time finding someone who's got a certain Digilant board to do artifact evaluation, on an Intel FPGA. So every design's slightly different. My group does a lot with the RF SoC, which is a communication FPGA with an RF front end. So I can't replicate it on AWS because it's different. So, and research papers published in these conferences tend to be, sort of on the edge. So new hardware, even if it's commercial hardware. So it's not one size fits all. And the tools now, except for a few IPs, are mostly unlicensed, so they are open, but putting them in a container, like I said, is just huge. So maybe the thing to do is convince AMT to come up with a version of the tools that's containerized, that's not 2 gigs.
So I have 2 questions. One, why not to require something like QEMU? And the reason why I'm saying that is, imagine that you have done this 20 years ago, and they give you a Sun microsystem platform base. So how are you going to reproduce that later in time? So I see some communities require that you have to provide a VM so that it can be able to run in an emulator, like QEMU or native you can, so that it reproduce later, so that you can reproduce later in time. And then the other one is some of the commercial tools, like you go on Synopsys, they are not allowed you to use for benchmarking. So how do you even deal with that? Silence is nice. They don't sue you anything. You report numbers, but the typical with Synopsys, we always say is not BCS, is the TCB or whatever. You just change the name because you cannot report numbers for them. So how do you deal with that if you do some reproducibility with commercial flows?
So I think that gets back to the earlier question about making this mandatory. There are people who don't want it to be mandatory because, like, if you're using Synopsys tools, Synopsys will stop donating you all their software if you publish results, right? But the FPGA vendors, so AMD/Xilinx and Intel/Altera, don't mind that you publish results. So that hasn't been that much of an issue. And then the thing about VMs is, once again, it doesn't play nicely with a lot of FPGA designs. It works sometimes, but there are a lot of cases where it just doesn't work nicely, especially where you're pushing the envelope with the hardware-software interfaces and things like that. So.
We've got 1 more minute. Tim.
Just FYI, I have a tool which will take the Xilinx tools and create a container, which is just the parts you use, which tends to be about 100 megabytes of that 20 gigabyte toolchain. So I can share with you. That's all open source. I used it for doing CI on like old Travis CI systems where you only get a couple of gigabytes worth of space. So we can chat about that later.
Yeah, please share that with me. That would be great. Thank you.
You should submit a PR to AMD for that one, Tim. All right, let's thank Miriam again. Cheers.